All right, let's get into it. Imagine you're on a hunt for the perfect AI, a brain that's not only brilliant, but also incredibly tough and efficient. And its job? To live on a satellite, hundreds of miles up, and watch over our entire planet in real time.
You know, every single second, our satellites are beaming down just a fire hose of visual data. It's this non-stop high-def movie of our world. But here's the thing, just having all those pictures isn't enough, right? We need to understand what they're telling us, and we need to understand it fast.
And that really is the multi-billion-dollar question. Our world is changing so quickly. We're talking wildfires, floods, deforestation, you name it. The speed at which we can analyze this data can literally mean the difference between getting ahead of a disaster versus just cleaning up the mess afterward. So how on earth do we keep up?
Well, to solve this problem, we need an AI that can win on what is probably the toughest, most unforgiving racetrack you can imagine. The inside of a satellite hurtling around the Earth.
So here's the big problem with the old way of doing things. A satellite takes a picture, a massive file, and then it has to slowly beam all that data back down to a ground station. That whole process can take hours, sometimes even days. By the time you get the info about a flash flood, the flood has already come and gone. It's just too slow.
The solution, then, is to flip the whole script. It's a concept called onboard processing. Instead of sending down the raw, heavy data, what if the satellite could just send us the answer? The AI lives right there, on the satellite, looks at the images the second they're taken, and just sends back a tiny message like, "Hey, wildfire spotted at these coordinates." This is a total game changer.
But, and this is a big but, putting an AI in space is brutal. Satellites have very little power to work with. Think more like a high-tech Fitbit, not a supercomputer. They have limited processing horsepower, and sometimes the images they capture get corrupted with noise. You can't just upload some massive power-hungry AI model up there. It has to be tiny, super efficient, and incredibly resilient.
So with that incredible challenge laid out, let's meet the main contenders in the ring, all competing to become the new brain for our eyes in the sky.
It really boils down to two main teams. In one corner, you've got Team CNN, that's convolutional neural networks. Think of them as the seasoned veterans of image analysis. They're reliable, they're well understood, and they work by looking at an image piece by piece, kind of like through a magnifying glass. And in the other corner, Team Transformer. These are the revolutionaries, the new kids on the block, using the same ideas that power amazing language AIs. They don't just see pixels, they see the whole picture at once, understanding how all the different parts relate to each other.
And this quote from the researchers just hits the nail on the head. It's saying that the same AI revolution that totally changed how we work with language is now storming the world of computer vision. It's a huge moment.
Okay, so to find our champion, these AI models were put through a kind of AI Olympics, a set of 3 absolutely grueling trials designed to mimic the intense pressures of operating in deep space.
And these 3 trials test everything that really matters. First up, the accuracy test. Just how good are they at getting the right answer under perfect conditions? Then, the efficiency gauntlet. How small and how fast are they? And finally, the toughest of them all, the robustness crucible. What happens when the data gets messy and imperfect, like it does in the real world?
So in Event 1, the pure accuracy test, a transformer model called MobileViTV2, we'll just call it MobileViTV2 to keep it simple, jumps out to an early lead, an incredible 99.09% accuracy. But here's the shocker. The biggest, baddest model in the competition, ViT-Huge, actually did way worse. It's a perfect example of something we see all the time in AI. Bigger is definitely not always better. All right, on to trial number 2, the efficiency gauntlet. And this is where things get really serious, because in space, size and speed are everything. An AI can be 100% accurate, but if it's too big to fit or too slow to run, it is completely useless for this mission. And the difference between these models is just staggering. It's kind of like comparing a heavyweight powerlifter to an Olympic gymnast. One is incredibly powerful but massive and slow. The other is lean, fast, and built for peak performance in a very constrained environment. So, how nimble are we talking? Well, get this. The entire EfficientViT-M2 model is just over 38 megabytes. That is tiny. It's smaller than a few photos you might take on your phone. We're talking about an AI brain that can analyze the planet from orbit, and it takes up less space than a music album. It's an absolute marvel of engineering. And that brings us to the final event, and honestly the one that might matter the most, the robustness crucible.
This is where we separate the lab experiments from the real-world champions. This is where we see how these AIs handle reality, because reality is messy. So, have a look. On the left, you've got a perfect, clean image, the kind you'd see in a brochure. But on the right, that's reality. It's the same image, but it's been corrupted with noise, static, and distortions that can happen for all sorts of reasons. This is the final exam. Can the AI still see the truth through all that static?
Okay, so after 3 grueling trials that tested for accuracy, efficiency, and pure toughness, a clear champion finally emerged from the pack.
And this is where the race completely turned on its head. When faced with corrupted data like motion blur, our early leader, MobileViTV2, it started to stumble. Its performance dropped off. But EfficientViT-M2, it held strong. It barely flinched, maintaining a much, much higher score. It just proved to be the tougher of the two.
And that's really the key takeaway here. While one model might have been a tiny bit more accurate in a perfect, clean lab, the other one was way more reliable when the going got tough. And for a mission this critical, that kind of reliability under pressure, well, that's everything.
And so, ladies and gentlemen, we have our gold medalist, EfficientViT-M2. It's the AI that had the best all-around performance. It found that perfect sweet spot, that optimal balance between being accurate, being ridiculously efficient, and being tough as nails. It is, simply put, the right AI for the job.
Okay, so an AI champion is crowned. It's a cool headline for the tech world, but so what? Why does this high-tech competition actually matter to us, down here on the ground?
Well, it matters because this champion makes a whole new generation of smarter satellites possible. We're talking about satellites that don't just take pictures anymore, they understand them. This means getting real-time alerts to firefighters during a wildfire. It means giving farmers instant data to help them grow more food. It means giving scientists the tools to monitor the health of our planet faster and better than ever before.
So this isn't just about better technology, it's about making better, faster decisions for all of humanity. And it leaves us with this incredible, mind-boggling question. Now that we have AI that can truly see and think from orbit in real time, what's the first global challenge we're going to solve?